attempt. Well, the way it really does it is by using this technology to create a black and white list of URLs. So what happens is Microsoft has this big distributed client honeypot network that's using high interaction technology. It's actually taking a virtual machine with IE on it, going out to a website, looking to see if it gets infected. If it does get infected, they take that URL and stick it on a list that gets distributed to people through Windows updates within IE7, so that if you're using IE and you go to a website that's bad, it'll pop up a box saying this is bad. So really, it's just a very interactive blacklist is what you're getting. Now, what's nice about it is that although it's slow, their use of virtual machines enables us to actually be pretty good analysis engine. They have used the other two Microsoft research projects, the Striker projects, called Ghostbuster and Gatekeeper, to build a pretty good system scanning capability. They can detect rootkits, they can detect malware, and they can detect what type it is, what it's doing. Very, very in-depth information from these two other projects. And that allows them to scan memory in addition to file system and registry, do really in-depth checks of what's happening. That, coupled with the virtual machines they have, allows them to easily detect 0 days by running the same URL across a set of virtual machines. One virtual machine could be configured with Windows 2000, one with XPSP1, one with SP2 fully patched. They can see if the same URL infects different hosts. And if it doesn't affect 2000, but it affects SP2, well, now it's giving them more information on how this piece of malware works, how this site is targeting users. Maybe they don't want the Windows 2000 users, maybe they only want the XPSP2 users, or if it doesn't work on the fully patched machine, well, it's not 0 day. If it does work on the fully patched machine, hey, it's something that our patch didn't fix, we need to look at this. So they can find 0 days with this as well. Now, from my interaction with the Microsoft team on this, which has been very little, it doesn't seem like it's being used very much. They have a pretty good idea. They built a pretty cool farm when they originally built this to get some good metrics. But in general, it's just being used to supply the IE7 with their information. Now, that may be wrong, though. Now, HoneyC is a relatively new appearance on the open source stage. It's low interaction, very simple. It basically is doing the wget request that I talked about earlier, but it's doing it in Ruby. So you give it a list of URLs, you give it, or a search engine and a keyword. It'll go out there to execute the URL or the search and get a list of that and keep feeding it in there. And as it downloads the HTML page, it just runs it against a list of snort signatures. So it's relying upon snort and the bleeding edge snort rules to find these malware downloads, these malware issues. So it's very reliant upon other technologies and on the signatures that are used in snort, which anybody's used snort from the bleeding snort rules list, they don't work all the time, so you can have issues. And the URL seed, again, is search engine based, which in my mind is a very bad way to go about starting your seeding. It is very just, throw something out there and hopefully you catch a fish. Well, I don't think that's a good way to start your prioritization of looking for malware. And there's no caching or correlation done like Honey Client. There's no cross-correlation of what URLs have been visited, what I found at this URL, when's the last time I visited. There's no information and no use of the data at all. It just spits it into a log file, and it's up to you to really look at it. Now, the sort of the granddaddy in my mind of client honeypots is McAfee's Site Advisor. And really, nobody's talked about it as a client honeypot, but that's really what it is. If you aren't familiar with McAfee's Site Advisor, it's a very simple application that goes out to websites, sees if it gets infected by anything, and by infected it means it actually uses antivirus to determine if it's been infected. And if it has, it marks that URL as bad. And then you as a user have a plugin built into your browser that when you go and do search engine searches or you go to a website, it tells you if this site has been ranked good or bad. Have people downloaded malware from this site before, yes or no? And that is empowering you as a user to not go to that site because, hey, there's been phishing attempts there. Now, they also integrate email and spam into this equation, but in general, it's just doing a massive web crawl and analyzing what's happening to the client when it goes and visits this website. Now, they built a very, very scalable, high interaction client HoneyNet. And this is a massive deployment, very, very big, but they focus on the data, which is what you guys are concerned with and what I'm concerned with in the end too, is, okay, I accessed this URL, I got infected. I have this piece of malware on me. What does that mean to everybody else? How can I help the community, or how can I understand that if I go back to this site and get infected again? And so it can tell you, this is a bad site, don't go to it, or somebody else said this is a bad site, but we checked it out and it's not, right? So you can get some more information. It does utilize signatures because it's based on AV. So this is why McAfee was a good fit for them. It requires the latest AV signatures to determine have they been infected. But they use the community to double check their data. I mentioned how a user could say this site's bad, but they check it's not, and vice versa. That's the first we've seen in this type of technology of a feedback loop. And I'll talk more about how a feedback loop is essential to this type of technology because what we perceive as bad may not be bad to somebody else. And then they also use email as well, which I'll talk about why that's needed as well. So what's the future of these things? We talked about 4 brief ones. They're very, very basic. There's not much been going on. We have this amazingly open technology here, but everybody's been focusing on the tools. Building cool little widgets that do things, that go out and download sites, and everybody's been focusing on that. And really only site advisor have they focus on the data. So the first thing we need to do is branch out more. We need to stop thinking about browsers. We need to start thinking about the client application in general, email programs, Office, Excel, PowerPoint. There was just a PowerPoint 0-day or something I saw on the mailing list or whatnot released. So there's other client applications that are being infected that we need to be concerned with. IE and Mozilla are not the 2 big targets anymore. But we need more data. We need to take this data, we need to collaborate it across multiple different types of data. So SiteAdvisor uses the data in one way, but that same exact data could mean something totally different to you. For example, they use it to determine if the site's bad. Well, I want to determine what type of malware is being delivered from that site, and if I link up the authors of those malware and maybe who owns the domain, am I able to find out some information on that? Geolocation information, things like that. Other data that could be useful to other entities derived by doing this type of technology. And then open community for data analysis. This is something that I want to help build with the HoneyNet project. Is if I have my own little HoneyNet here of client honeypots gathering data, and you have yours over there, and somebody else has theirs, how do we put our data together? I'm crawling this part of the web, you're crawling this part of the web, and the web's huge. So how do we go ahead and consolidate this data together to learn more about it, and to learn more about the malware that's being downloaded, the exploits that we're seeing, and things like that. Now, tools are not the answer to that, so I'm hoping that we'll be able to use these tools and realize that they're a means to an end and not the end goal. And then also use more tools to build automated analysis here. These communities can be fed data, and a lot of information of this data can be automatically analyzed and determine, have we seen this malware before? If we have, what information about it do we know? Is it linked to another site, etc.? So there's lots of data. Now, where do I want to go? I've analyzed these 4 sort of client HoneyNet technologies that are out there, and so I have my own ideas here. So these are purely my own ideas of a client HoneyNet and a honeypot that I will be building for the HoneyNet project. I don't have a demo right now, but it's actively being developed. And one of the main goals was modularity here. As you saw with all the other 4 different projects, they're all focused on URLs or driving the browser integration, that type of thing. What I want to be able to build here is a modular structure that can take inputs from anywhere. So perhaps I'd like to take my spam filters. I'm now blocking all this spam. I know it's spam. Well, let's extract the URLs and see if I put that URL into my system, if I go get infected by going to look at this Viagra pill or whatever it may be. So take a lot of different inputs into the system as opposed to just a static list of URLs I feed it every day. Make it autonomous. Make it grow on its own. So I get email as an input. I can get Craigslist postings. I can get eBay postings. I can get things like that I can sort of feed in that'll help drive my URL searching. It definitely has to be high interaction because of the data we want out of it. One of my goals with this is to get as much data as possible to the function level. I want to be able to see what function calls are executed by the malware after it was downloaded. So I need to know things like what type of malware this is with all the packers that these various bots are using. I can't just do an MD5 of the binary and say I've seen it before. I want to see what it's doing. Is it a variant? Is it what is it doing to the machine? And be able to get that as time's going on. Thorsten talked about in his talk earlier today about a method for doing this with CW Sandbox, and it's a similar type of idea. Running an application, run for a little bit of time, gather some information on it, and using that information to further our research. But one key piece here is utilizing low interaction client HoneyNet technology in this high interaction honeypot. So there is a value in these low interaction tools in that they do some cursory analysis. If I can easily do one simple request, match it with a signature that it is a this type of exploit, well then I can take that data, know that it is an exploit, know that it's categorized as something over here, and then as time permits, feed it into my high interaction system to get more detailed data. So you can use low interaction plugins for your essential gathering and assessment of certain sites. Does it pass the sniff test essentially? And then build a community through the HoneyNet project, through the HoneyNet's website and the HoneyNet's alliance of members to help take this data and build the data. So there's a alliance project within the HoneyNet project, which is a grouping of people all around the world that put data together and analyze it. And so we'd like to build on that with this type of data, client data. And then also I'm envisioning a distributed IE plugin, which is the last step to this whole process. This IE plugin, I got the idea from McAfee's Site Advisor, but a little bit different. Instead of the plugin telling you a site's bad, the plugin can actually execute these little quick signature-based no-interaction queries for us, as in us being the project. So you're browsing as you're going to CNN, you're going to different sites and whatnot. It is just a signature-based check of what site you're on, determines if anything bad happened, and if it did, it just logs and records it, and then you can submit that to our system as you like. Now, this distributed IE plugin keeps our data current, which is a problem that highly scalable systems have. They're trying to go out and get every single URL out there. They just want to get the whole web. Well, the problem is the whole web doesn't matter to most users. You have a set pattern of websites you go to, a set pattern of sites you trust. So the question really isn't, is this URL that's way off that only one person's accessed in 10 years going to infect me? It's more of, well, is the site Amazon.com all of a sudden got an issue and I just got infected with something? So there's that type of situation. So a distributed plugin built into a standard user's operating environment where they don't even realize it's happening behind the scenes can help us get a lot of current and relevant data. So the general architecture of this is very simple. Follows the Gen 3 architecture from the HoneyNet. Now, you may not be familiar with that. It's very simply just your standard central server to receive all your data and a whole bunch of sensors across the world. The centralized collector is needed because when you have these one-off systems just sitting there running and chewing on URLs, they can go over the same URLs 10 times and not even know it. They can be seeing the same malware 100 times and they have no intelligence built into them. So the centralized collector can help correlate URL lists, can help reduce duplicate data that we've seen, decrease the number of actual assessments that have to be done on the sensors. It can provide a list of URLs to clients. So maybe we're going to take in that spam feed, or maybe we're going to monitor an IRC chat room for URLs that pop up and feed that into our system. So that feed can come from the centralized collector and be distributed out to sort of the drones to do the work. The community, like I said, visits the same sites over and over, but not the new ones. So the centralized collector can be the way to get the new sites out there, while the community is building or continually going over the sites every single day. There's going to be a client-side kernel filter to help determine exploitation. So the next slide I'll talk about in more detail what that is. But it's important to note that a lot of the tools right now are user mode based. They're just doing a simple different diff check. You check the whole file system, check it again, is there a difference? If there is, then something happened, you should look at it. We're going to go more towards an approach that gives a little bit more scalability, a little bit more capability to determine really was I exploited or was I not. Now, the general approach for these things has been a simple, diff check, like I mentioned. There's been some talks of moving into this, away from the signatures into something more advanced, because those signatures are very content-based. They very simply just go after, whatever's there. They can't understand JavaScript, so if there's a time bomb in there, so for example, you have a JavaScript command that says, wait 4 minutes before executing this code. Well, in a general signature-based thing, it may not be looking for that time bomb to redirect you to a bad site. It just says, oh, there's nothing there. Or if you have a general system where it's just monitoring what the browser does, a time bomb can cause an issue because you may have already browsed away from the site before the exploit occurred. So what we try to devise here is a client architecture using a kernel filter driver to profile IE, similar to Neil Provost's systrace functionality. We basically baseline IE and say this is what it generally touches. It touches these directories in the file system, touches these folders in that directory, and that's about it. So anything out of this very simple baseline is an exploitation. And since we're controlling both the operating environment and the browser in this situation, we have full control. That baseline can be a pretty accurate baseline. So any functions executed outside of this profile need to be examined and cause basically an alert. Now, if you've heard this before, it's because of the standard HIPS approach to sort of monitoring your application and machine. So taking the same HIPS-based approach, which is a host intrusion prevention, but instead of alerting or preventing the operation from occurring, we're just going to log it and take that information and feed it back into our system. and go ahead and start looking at the binary to see what happened. Now there are problems with this architecture